Let's go to our first example problem. Practice problem number 1. So you should flip to your sheet just like I'm doing so you can read practice problem number 1. And I've left you some blank space to do it on your own on a practice sheet. Here's what you're going to do. For practice, Pedigree practice problem number 1, the outline of the problem is we've got the trait of, I believe it's baldness, right? Yep, baldness is the trait we're concerned with. Good old male pattern baldness. Being bald is the recessive allele. And you're going to draw a pedigree that shows a homozygous recessive male and a homozygous dominant female having 4 children. 2 are going to be boys, 2 are going to be girls. And you're going to draw a second generation girl marrying a heterozygous male and having a child. And you're going to assume the third generation child is a female. What are the possible gene combinations for this female? So let's go ahead and draw a pedigree. These are the types of questions I'm going to ask you on, like, I don't know, a quiz or Friday quizzes that are coming up. So you should definitely follow along and understand how to draw this pedigree. So let me show you how to do it right now. First thing I'm going to do, I will start by drawing a male and a female. So to draw the male, just like I said before, to draw the male, you'll draw a square. Males are always represented with squares. And females are always represented with circles. And notice that I drew a horizontal line connecting the two, which means that mating has taken place. This boy has mated with this girl. Okay, so let's see here. Homozygous recessive male. So if he's homozygous recessive for baldness, he's going to be all the way filled in. So I'll fill in the whole square. Ta-da. And then let's see here. And it's a homozygous dominant female, so she's all set. She's not filled in all the way. And they're going to have 4 children. So what we do is we drop a vertical line down because that means the next generation is being produced. And they're going to have 4 children. So what we'll do is have 1, 2, 3, 4. Okay? And it said 2 are boys and 2 are girls. So here's their kids. There's 1 boy kid. There's 2 boy kids. Here's a girl kid. Here's a girl kid. Okay, so far so good. Now, in the question, it doesn't tell you the genotypes of those children. But if we've got up here at the top, we've got a homozygous recessive male, and he's having children with a homozygous dominant female, that means these kids have to get 1 allele from dad and 1 allele from mom. This kid's got to get 1 dominant version and 1 recessive version because that's the only combination you can get with those parents. If you don't believe me, you could do a Punnett square. So this kid will be half filled in. This kid, whoops, wasn't a very good dividing line. That kid will be half filled. And again, the half filled represents a heterozygous genotype. I'll probably ask you quiz questions that ask you what these things mean. You'd have to use words like heterozygous and homozygous. You need to know what all that stuff means again. Okay? So far, so good. Now I said, draw a second generation girl marrying a heterozygous male and having a child. So, which ones are girls again? Well, circles are girls. And who's the second generation? Up here. This is generation number 1. These people up here are generation number 1. They give rise to generation number 2. And notice I can tell if these people aren't mating, there is a line connecting these squares and circles. But see how the line drops in from the top? That type of connection means siblings. But the connection we're going to draw here in a minute means mating is taking place. So it's a different kind of line that connects them. So we said the second generation girl is going to marry a heterozygous male. So we'll draw a heterozygous male over here. And if I were to draw a line like this, that would mean that they are brother and sister. But that's wrong. We don't want a line like that. We don't want to show that they're brother and sister. We're going to draw a different kind of line. We're going to draw a line like this. And what that line means is that this guy is married into this family. He's mating with this female. Okay? And they're going to produce some offspring. So to show the third generation being produced, we drop a line down. And let's say, we're going to assume the third generation is female, so what should I draw there? There's our third generation. And assume third generation is female. And question number 3 says, what are the possible gene combinations for this female? Well, that female really could be pretty much anything. So she could get the recessive allele passed down. She could get the dominant allele passed down from mom. She could get the recessive or the dominant allele passed down from dad. So this could be not filled in. It could be half filled in. It could be all the way filled in. We don't know for that individual. So we're just going to leave that one blank. Or actually, we can't leave it blank. We'll just leave it with a question mark on it because we don't know what the genotype of that offspring could be. But that's how you draw a pedigree. So now what I'd like you to do is turn to the second problem in your packet here.